Underwriting for Autoline this week is provided by...
Did you know advanced high-strength steels are the leading material used by automakers to achieve the new fuel economy standards? Advanced high-strength steels are lighter in weight and reduce greenhouse gas emissions without compromising safety, performance, or affordability. Steel, a sound, sustainable investment. Today, tomorrow, and beyond. For more information, visit autosteel.org.
You know why I pulled you over, ma'am? I need you to recalibrate the Doppler shift on the return signal. Radar's on the frisk.
Do Sonata drivers know something you don't? The Sonata from Hyundai.
And now, here is your host, John McElroy.
The cars we drive today are going to be very different in the future. That's because automakers have got to greatly improve the fuel economy of those vehicles, and a key way to do that is to make them lighter. That means they're going to have to experiment with all kinds of new materials. But which materials are those going to be? Well, to help me get to the bottom of that, I'm joined today by Ganesh Paneer, the Director of Sales and Marketing for Automotive and Specialty Products from Novelis North America. Novelis, by the way, is the largest producer of rolled aluminum in the world. We're also joined by Rose Rintz, the Senior Director of IAC Advanced Development. IAC is a company that supplies interior components to the auto industry, but with a specialty in plastics. And Blake Zeidema is the Director of Automotive Product Applications for ArcelorMittal USA. And of course, ArcelorMittal is the biggest steel company in the world. And with that, let me start with you, Blake, because steel dominates the way that we make cars today. Always has. I think it's going to in the future. But those steels are changing. And it's been very impressive to me to see how much lighter cars are getting just by using steel. What's changed in your view?
A number of things. Most of it has to do with getting the right strength grades of steel into the right components. And the steel industry has spent a lot of effort over the last few years understanding car designs, looking at the design and performance requirements, finding out what material properties are associated with those, and then developing steel grades that specifically target the kinds of properties that are needed in those things. And a lot of the advanced steels that are coming into the market right now are basically designed to maximize performance within those design requirements.
Okay, for a layman like me who knows nothing about how this works, how do you make steel a whole lot lighter and stronger at the same time?
You make it stronger. You provide more energy absorption so you can use less of it. A lot of the weight reduction has come through using stronger grades at lighter thicknesses.
And yet, Ganesh, even though steel is getting lighter, you make aluminum and it looks like business is booming for you guys.
Yeah, absolutely, John. In the next 5 years or so, we project about 25% growth in the market for aluminum, and primarily because of the CAFE regulations that's coming up, the first 2016, which the companies have to hit at 34.5 miles per gallon, and the 2025 regulation, that's the 54.5 miles per gallon, which is a bigger target, right? So these are the bigger drivers for us in the industry. That's creating a lot of pull from the OEMs for aluminum.
And we're seeing aluminum being used in all kinds of things. The engines, the transmissions, the chassis, the body, everything.
And if you traditionally look at it, aluminum has made a good penetration in the engine cylinder blocks or suspension components and so on and so forth. But from the body in white perspective, aluminum is starting to penetrate. And the study that was made by Ducker for Aluminum Association, you'll see that the aluminum content in a vehicle is going to go from about 300 kilograms, 300 pounds a vehicle today to about 550 pounds, right? That's nearly doubling. And a lot of this growth is primarily going to come from sheet aluminum that is in the body in white areas. Examples like hood and roofs and deck lids and door systems and so on and so forth.
And yet, Rose, plastics is are growing as well.
They are indeed. We're pretty flexible. We like to say plastics are used for a majority of reasons. If you look at the amount of aluminum or steel that's used, at equivalent strengths of materials, you can use half the amount of plastic. So it goes a long way toward trying to reach the type of weight reduction and so on. The other thing that plastic has, all the way from high strength, but really good ductility, so real good impact resistance. So when you look at, for example, an instrument panel or a door or a headliner for that matter, all the type of side curtain airbags and type of performance that we need to get to are already inherent in the plastic itself.
But just as Blake talked about different kinds of steels, there's all different kinds of plastics.
Well, there are indeed. A lot of people, I think, look at plastics and say it's another outgrowth of oil. Yes, it is, the same thing that you make gasoline from, but the beauty in plastics is we're starting to reinforce them with some natural fillers, some corn stalks, canaf, jute, bamboo for that matter, and it allows us to increase the weight, or decrease the weight and increase the strength even more to get towards the kinds of high strength properties that you need for thin wall materials.
I understand IAC has come up with some sort of blend of its own of plastics.
IAC is a unique interior company. We call vertical integration one of our strengths, and in vertical integration, to define that a bit, we take the different materials that could make up a plastic, blend them together to get very special attributes of that material. In doing that, we can go thinner wall. We can put in things like recycled carbon into our formulations. And if you look at the types of things we do, all the way from instrument panels to doors, to headliners to carpet, everything virtually in the vehicle, interior of a vehicle, minus the seats and electronics, we do. And we can custom tailor our blends to get to the certain attributes that we're looking at, from touch and feel and thermal management, all the way to impact resistance and other properties.
Blake, you got to be worried, or are you worried about all these other materials that automakers are starting to look at? Because people's perception is steel is just heavy.
One must take the competing materials threat very seriously, because we still don't know exactly where we're going to be in terms of the actual fuel economy requirements, nor in terms of the cost of some of the other fuel economy improvement technologies. There are thresholds beyond which some of these other materials could make very good economic sense. But from what we have seen right now, the weight reduction potentials offered by today's current and emerging steel products provide sufficient weight reduction to get us to a 54.5 mile per gallon fleet within some of the reasonable assumptions. Now, will that do that for all vehicles and all manufacturers? That's where some of the risk comes in. There are going to be niche applications where we're going to have to look very seriously about some of these other materials.
So as you look out down the rest of this decade, what percent of cars is made out of steel right now, and where do you think it'll be 10 years from now?
Oh, 10 years from now, steel is going to be a significant part of the fleet 10 years from now. Particularly in some of the smaller vehicles, the ones that already are closer to their fuel economy targets. These vehicles don't have the same real demand for weight reduction as some of the other ones. The areas perhaps of greatest interest in potential are the bigger vehicles. They're further away from their goals, they have a lot longer to go, and some of the other technologies are a little bit more expensive to get these things way up to their targets.
You're talking big SUVs, pickup trucks, and
large passenger cars, pickup trucks, and the like, certainly.
Ganesh, I got to believe that part of the challenge that aluminum has in selling to the auto industry is the material itself is more expensive, but it's also going to require other manufacturing techniques. The way you stamp it and weld it together has all got to be different. So there's not just the cost of the material, but changing the assembly and manufacturing areas.
The way to look at it, John, is really if you look at it by component, aluminum is lighter, but it's more expensive by the pound compared to steel or other materials. The right way to look at it is look at it as a system-wide solution. If you put a set of aluminum components together and get the right durability and the crash performance and safety performance for a vehicle, you would be actually able to design a body-in-white system that is lighter, that's about the same level of cost as steel, and still provides the performance or exceeds the performance level that's been set forth by the OEMs. The classic example is the Land Rover, the Range Rover SUV that you have probably seen at the Paris Auto Show. Right?
Yeah, the new Range Rover SUV, they took, I think, an average of 900 pounds of weight out of the vehicle, largely by going with so much aluminum in
Exactly. The other examples out in the market are the Jaguar XJ, the XK, and Audi A8. And some of the performance vehicles have taken the limit to the other side, have gone into highly aluminum-intensive vehicles.
They tend to be lower volume vehicles, certainly. Do you think we're going to see aluminum-intensive vehicles in very high production?
We think so. Given the CAFE regulations that's coming up and the targets that the OEMs are against, there has to be a solution that involves aluminum heavily, right? And also multi-materials like plastics and steels and so on and so forth should have to be a part of the solution to achieve the targets.
Rose, of course, one of the things that people always bring up, in fact, you brought it up earlier, plastics are made from oil. If the price of oil goes up, isn't the price of plastics going to go up along with it?
For sure. Absolutely. The price will go up as the price of a gallon of oil or a gallon of gas or whatever else goes up. They're all predicated on oil to begin with. I think what we're trying to do to eliminate that cost target out of plastics as oil goes up, plastic goes up. We're filling it with things, as I said before, with fillers that aren't expensive, that are natural, that are not petroleum-based. We're also going as far as looking at recycling efforts, which I think plastic have a tremendous advantage in. How much recycling can we put back in and still get the same performance? So although we may be using 1 pound of material that might come from, a tenth of a gallon of gas, we might indeed be using more of that as a recyclate, therefore diminishing the amount of oil that we need to get out of the ground to make the original plastic.
When I hear things of jute or soy or these other natural materials going in, is that just to create an environmentally, benign or positive image about the material, or does it really lower cost or boost the strength?
Well, I think you have to look at several things. We look at carbon credits as well when we look at reinforcing plastics, or where we would get the KNAF or jute from if we're filling it. The disadvantage now is that in using KNAF, for example, which mainly comes from Bangladesh, from India, when you look at it from the perspective of, yes, I'm reducing the amount of oil I need, you're looking now at carbon credits. How much does it cost to ship that across the ocean in order to put it in a vehicle? So we're really looking at less dependence on oil. We're looking at increasing stiffness so that we can go to thinner wall and go hence to lower weight. I think the real advantage or disadvantage, whoever can figure out the solution, is going to be, how do I get the right amount of filler at the lowest cost and still say I have a green, environmentally friendly solution? I think right now when you look at natural fillers or natural polyol, such as soy from sugar or other sources, it's generally more expensive. So the company or the person or the material that's developed, the first one to get there with a cost-effective solution with lighter weight and natural-based materials is going to be the real winner.
Rose, how does that affect the manufacturing process, though? It's one thing to have these materials and their performance attributes, but do automakers have to change, or suppliers even have to change the way they manufacture with this?
That's a great question. If I back up for a minute, part of the total cost of a part is in the capital that you use to, make the tools, to get the material, and then to manufacture it into a molded part or a stamped part. With plastics, we really do not want to change the manufacturing process because there's inherently a lot of capital in our plants, and other people's plants for that matter. And one thing that's very specific to plastics, you can't change a tool to get a similar fit next when it butts up against sheet metal. For example, if I make a plastic door and it's next to a steel fender, I need to make sure that gap or distance between the door and the fender stays consistent. So to get to your question with that premise, when we put fillers in, or when we look at natural products, or we even look at soy-based or bio-based type plastics, the fit must be exactly the same as it was before we did that. So typically what we'll do is we'll look at either implementing them in a new design so we can change the shrink or fit of that tool, or put enough of that in to an equivalent, say, talc-filled product so that it will be the same size, same fit and finish.
Same question to you, Ganesh. As we talked earlier, you've got to change some of the things that you do in manufacturing. When you stamp aluminum, there's more spring back, so you have to take that into consideration. Earlier this year, General Motors announced that it had come in with maybe something of a breakthrough in how you could spot weld aluminum together. Do you see it the same way as a breakthrough?
Absolutely, John. If you look at manufacturing of aluminum, even though sort of fundamentally it's a metal similar to steel, metallurgically it's quite different. It springs back, and the stamping and the forming has to be understood very well by the engineers and the OEM community in general. Right? That's the first part. The second point, putting aluminum together, joining them either through rivets or laser welding or spot welds, there is a lot of breakthrough that's been happening, and more has to be done, right? Especially when you're talking about doing this on a building on a mass scale, right?
So what we see in aluminum cars right now is mainly riveting or laser welding.
Exactly. Primarily, you would see riveting, and riveting
That's got to
adds a
be
weight.
slow and cumbersome way of joining cars together.
Exactly. Spot welding has been proven itself over the years, and that's what the manufacturers are trying to get to, spot welding aluminum. And there's been some breakthroughs. For example, the rivet spot welding that GM has done through with by removing the oxide layer that falls on the tips.
I was very impressed to see that GM has been using this process without telling any of us in the media about it, or the outside world for that matter. Yeah. How soon do you think that this process might spread across the line, so to speak?
I can take, and in the next 4 to 5 years, they could fully get it into their lineup as I see it.
Mm-hmm. Blake, one of the advantages steel seems to have over every other material is, it's been around for an awful long time. So out in the field, at the dealership or repair shop level, everybody's got all the tools that they need and the knowledge to work on steel, don't they?
Mostly. I think most of the tools are out there. You repair cars by cutting pieces out, welding things back in, and the basic repair procedures have not changed that much. What we have to be careful of is making sure the repair shops are aware of which grades of steel are in which parts of the car. It's very popular to put a frame up on a rig and heat it full of torch heat input and bend the things back in. If you do that to a dual phase or a martensitic rail, you're going to completely anneal it and destroy the properties. So there's a big effort going on to educate the repair shops, and it's the steel guys, as well as we're working very carefully with the car guys and the repair folks to make sure that dealers and repair shops alike are educated.
How do you keep up with that if you're a repair shop? Because, as you're pointing out, all these new steel grades are coming out. They're going in different places on a car depending on which model and which car company you're talking about. And this is happening at an accelerated rate. How do these shops keep up with it?
The shops themselves have repair procedures that are provided by the OEMs. Now, I'm not an expert in repair. I've worked a little bit with the repair guys, but my understanding is each new vehicle has a repair procedure. And laid out in there are exactly the types of procedures, bend, repair, replace, and as long as the repair shop is reading those and adhering to them rigorously, the repair should be made in a safe manner.
John, that's not so different from plastics. When you think of the number and type of plastics that go into the interior and the exterior. For example, when we switched from what we called xenoid bumpers back in the early 90s, late 80s, to olefinic bumpers, completely different repair procedure. So we put out service bulletins through the OEMs to make sure that they were aware that it had changed and it would require a different finish or a different fix to repair that particular item.
How was the experience in the field with that?
I would say initially in going from what we would call a very amorphous type, non-shrinking, easy to adhere to bumper to a Teflonish type bumper, it was difficult. I think you would have seen a lot of early vehicles not repaired correctly where you would see pieces of paint off of the bumper, for example. That was because of either an incomplete repair or not correct repair. But I think as we learn with anything, any change, it becomes relatively easy now when you look back and say that was an easy fix.
Ganesh, it's one thing if the bumper doesn't look all that good. It's another thing if the whole frame or chassis of the car is not properly repaired. Yep. How's aluminum going to deal with that, of this learning curve that's got to take place out in the field?
Yeah, the challenges are quite similar, John. If you look at the type of alloys that go into making aluminum, there are probably about 5 or 6 different alloys, particularly customized either for skin applications that get the crisp lines that's needed, or the crash applications where it has the strength or the deep draw that's required for inner panels and so on. The right alloy and the material has to be put at the right place. The joining types have to be done right. So there's a lot of learning and education that needs to be done in the service sector. Particularly the OEMs have to take a lead and walk through the education throughout the process.
I imagine it's one thing if, you mentioned Audi and Jaguar Land Rover. It's one thing if people bring their cars back to the dealership and there's more control over how these things are repaired and made sure that they're done properly. What happens when they get out in the independent repair shops?
That's certainly going to be a challenge. The independent repair shops are going to be quite surprised with the material that they see in these cars, and the fear is, doing improper repairs may lead to liability and so on and so forth.
Yeah, that's one thing that I don't think the regulators maybe take into consideration. It's easy to say, oh, you got to make the fuel economy better. Yeah. Then you start to run into all these real-world issues, let's call them. And another thing, too, even though fuel economy, Blake, is driving all this, what about total sustainability? It's one thing to make a car lighter for the time that somebody's going to be driving it. Ultimately, it's got to be recycled, and hopefully that material be used back in the manufacturing process. What's steel's take on this sustainability issue? Well,
steel has an advantage going in because there is already a very, very prevalent recycling program going on. I've seen some of the statistics from the Steel Recycling Institute, and depending on the year, the rate of auto recycling varies from probably 98 to 101%.
101%? We recycle more than there are.
Sometimes we recycle more cars than we actually make. And because much of the steel is magnetic, it's fairly straightforward to bring it out. So that is going to continue. Now, there are a lot of other sustainability issues. We have to look at total carbon footprint. Even though steel vehicles are, on average, slightly heavier than some of those of the other competing materials, steel has another advantage in that the energy to produce it in primary metal form is quite a bit lower than some of these other materials. And certainly as cars get better and better fuel economy, the manufacturing CO2 emissions phase becomes more and more prevalent. And so that's something we have to worry about. We have to make sure we're not getting slightly higher, slightly better fuel economy and yet putting more CO2 in the environment. And then the other one that I don't think anybody has really touched upon is steel is made in the United States. We mine the ore here, we mine the coal here, we mine the limestone here, and we do all of the primary conversion to steel here in the United States. And that's not necessarily the case for these other materials. So from a long-term jobs standpoint, that's something else we have to think about.
Good point. Ganesh, what's aluminum's story on sustainability?
So here's where, John, we think we have the biggest advantage. Aluminum is infinitely recyclable. Right, so you can take aluminum and convert it into the same form, the same original product that it came from. The material doesn't degrade. You can do it infinitely over and over. And compared to the energy that it takes for primary aluminum to produce, the recycled aluminum takes only about 5% of the total energy. And we as a company try to promote about 80% recycling input for us. And that's where we want to go to, particularly in the automotive sector. Unlike steel that's far mature, aluminum is not. Right, so we need to set up sort of closed-loop aluminum recycling process to recover the steel, aluminum, and put it back in the process.
Rose, same question.
Well, the plastics industry recycles a lot, and not just from virgin automotive parts into virgin automotive parts. We also take, for example, baby diapers. We could put those into certain applications.
I hope you clean them first.
Well, odor is certainly one of the requirements. But yeah, we, from a capability standpoint, we could put anywhere from 5% up to 100% of recyclate back into the material. And we can even mix materials at times. So really driven by what kind of properties it needs, and blending is everything, right? We can blend one part with another and get very similar performance.
And when you look at the CO2 footprint of plastics, what's the story on that?
Well, much as Blake said with the steel industry, we also, if you look at oil, which plastics come from, the plastic plant is generally right at where the oil is refined. And to us, everything is about shipping. When we look at carbon footprint, it's putting the manufacturing facility for that plastic component very near to where the car is going to be produced. So, from a supply chain perspective, we produce with American-made oil. We try to do it at the same facility, and those plastic pellets then are molded into a part very near the assembly operation, so our carbon footprint can be very low.
Blake, how much do the car companies care about carbon footprint? When you go to sell to them, I got to believe, number one is price. Then, of course, you got to have all the performance attributes and all. In Steel's discussion, does this come up at all?
It does, and in fact, we are frequently asked for information specifically on the carbon content of steel. The challenge, though, is it's difficult to translate that into a final car's footprint because there are literally thousands of components, each of them having thousands of individual components. So keeping that accounting going has been something which is extremely, extremely challenging for them.
And Ganesh, do car companies ask you about carbon
Absolutely,
footprint?
especially particularly with aluminum's recyclability. We get a lot of questions on what's the carbon footprint for aluminum body in white that we are going to supply, right? And for example, some of the manufacturers like Daimler, you could go to their website and they are very meticulous about tracking their carbon footprint for their supply all the way back from mining all the way down to the aftermarket and service and sales.
You mentioned Daimler. Isn't that more important in Europe than just about anywhere else? Being able for a car company to track what its total carbon footprint
Absolutely.
is?
I mean, historically it's been stronger in Europe, but we see that momentum coming towards North America as well. And believe it or not, even in emerging markets like China and India.
They ask you that too, Rose?
All the time. We, in fact, when you start putting in fillers, as I mentioned earlier, when you talk about Canaf coming from India, that obviously would have a very large carbon footprint. So what we're doing is looking at alternative fillers that are grown and raised right here in the United States that can be used to lower that carbon footprint.
Just amazing. You know, here we are talking all these different things. You all are talking up each and one of your materials. I can only imagine what automakers and suppliers have got to go through as they design the thousands of parts that go into a car. It's got to be just a real challenge for them to try to figure out the proper material to make anything out of. But I want to thank all three of you for having come in today. You sure raised some very interesting issues, some that I want to dive more into. But Ganesh Paneer from Novelis, Rose Rintz from IAC, Blake Zeidema from ArcelorMittal. I want to thank you all for having shared your time with us and your knowledge.
Pleasure to be here.
And I hope you all enjoyed it too. And as you can imagine, if you had trouble, some struggle keeping up with all this, just imagine what the car companies are going through. Anyway, join us again next week for Autoline This Week.
Underwriting for Autoline This Week is provided by...
Did you know advanced high-strength steels are the leading material used by automakers to achieve the new fuel economy standards? Advanced high-strength steels are lighter in weight and reduce greenhouse gas emissions without compromising safety, performance, or affordability. Steel, a sound, sustainable investment. Today, tomorrow, and beyond. For more information, visit autosteel.org.
Why?
Because plants need water to grow.
Because baseball's played in the summer.
Oxygen and hydrogen.
Because I forgot to get a receipt.
Why?
Why not?
Why?
Why don't you go ask your dad?
Do Sonata drivers know something you don't? The Sonata from Hyundai.